This video will be on section 8.4, quadratic applications, or word problems. And that's all there is to this section. Now, when it comes to word problems with quadratic functions, we're not really in the kind of class where we can come up with equations for them. It usually requires something using physics or just formulas from business applications and things like that. So in these problems, you'll be given the formula every time. It's really, you need to know what it's asking for. And very often when you're given a quadratic function and you want to fulfill a word problem, you're going to do one of two things. You're probably going to find the vertex a lot. In these problems, it's just not going to say find the vertex, it's going to say find the maximum or minimum of something. Now, the other thing you might use quite a bit is the quadratic formula. You probably won't get anything you can factor in this section. The quadratic formula will pop up really to solve any question that's not finding the maximum or minimum. But in these, you are going to have to plug in something, set it up correctly. So we'll see how that works. So I got two examples to show you because they're really all the same. This first one is not a visual one, and the second one is a visual one, which you'll see what I mean by that. All right, so this first one, it says, suppose the sunglasses hut company has a profit given by P of Q equals negative 0.02 Q squared plus 3Q minus 40, where Q is the number of thousands of pairs of sunglasses sold and produced, and P of Q is the total profit in thousands of dollars from selling and producing Q pairs of sunglasses. All right, so it's a lot of information. Really, all you want to take from this is the equation and the fact that the Q is the number of sunglasses in thousands. That's going to be important for the answer. And then P of Q is the total profit in thousands. So when it comes to the final exam, I always like to mention this. You'll have pretty much word problem from each word problem section on the final exam. And you got to know what you're looking for then, because they're not going to be just in this section. Notice here that we have a Q squared. That's telling us that we have a quadratic function, not the Q, but the 2 exponent. Right, when we did the previous section of applications, which were linear applications, we had no exponents. It was just finding the slope, and we had like mx plus b, no powers. All right, so the first part of the question asks, how many pairs of sunglasses should be sold to maximize the profits? Right, as soon as you see this word maximize, you should be thinking of vertex, because that is what is going to tell you the maximum. So the vertex tells the maximum. Notice that this parabola opens down, so it's going to go along with it. It's not going to ask for the minimum if it opens down. It has to go with the maximum. But we can go ahead and write it in since the parabola opens down. Okay. And it's asking for how many pairs. So what part of the vertex do we want? How many pairs of sunglasses? Well, that's what Q tells us. And Q is really where X is. So what is the X formula for the vertex? It's, well, I have it written up here. negative b over 2a. B is 3. And a is negative 0.02. Now, if you want to do this in your calculator, go ahead. Just make sure you're careful about it. So we got negative 3 on the top, divided by, since I have a multiplication down here, don't forget to put a parentheses. Make sure everything goes into the denominator. 2 times negative 0.02. Oops, not the extra 2. And you get 75. Now the thing to remember here is this is the number of sunglasses in thousands, because that's what our letter's telling us. So the answer to this question, what do we want, or how many pairs of sunglasses should be sold? It should be 75,000. Now the second part here says, if necessary, round to the nearest whole number. Just do that at the beginning. So if you had like 74.5, that would round to 75, and then you would have this as your answer as well. All right, part B. This is usually the next question that's natural to ask. If you know how many pairs of sunglasses should be sold, well then, what is the actual maximum profits? Profit is taking the place of P of Q, which is Y, so it's wanting the Y value of the vertex. Since we want the Y value of the vertex, once again, the maximum is what's telling us vertex. We plug in the X value of the vertex. Right, just like we did in the previous section. Now be careful here, you have to plug in this number because the formula is using this. It's not using the actual number of thousands. Okay, so we plug in 75, we get P of 75 equals negative 0.02 times 75 squared in the place of Q, plus 3 times 75 minus 40. And once again, if you want to use your calculator with this decimal and everything, that's more than okay. So we got negative 0.02 times 75 squared plus 3 times 75 minus 40. And this gives us 72.5. Right, so this is in thousands. So we want 70, our profit is going to be 72.5 thousands. Now, one thing I'll double check and add in the comments here is, how do you get your answer? Should I round this first and then multiply by 1,000 or multiply by 1,000? But the way I would do it, I didn't program the problem. I would just multiply it by 1,000. If you multiply 72.5 by 1,000, you get 72,500 as the maximum profit. If you round first, then multiply, we get, you would round this to 73, so it'd be 73,000. All right, so what I'll do, like I said, I'll check for you and tell you which one is the correct way it's programmed. and I'll write it in the comment in the video section. All right, so really all we answered here, what is the x value of the vertex, what's the y value of the vertex of this equation to find the maximum. And once again, interpreting results with word problems, always got to be a little careful. Not all of them are in thousands or anything like that. So if you get 72.5, that might very well be the answer to the question. This one's just in thousands, so you have to be careful. All right, so the last question I have here is a visual one, and it's going to use the vertex and the quadratic formula and that kind of stuff. That says an object is thrown upward at a speed of 77 feet per second by a machine from a height of 12 feet off the ground. The height h of the object after t seconds can be found using this equation. H equals negative 16t squared plus 77t plus 12. In all the questions below, give your answers correct to 2 decimal spots. The reason why when you throw something up and it falls back down, kind of think about throwing a ball or something, is that it makes a parabola, upside down parabola shape. All right, and you can see that reflected in the equation if this is an upside down parabola equation. For people that may go on to take physics, this is studying something called projectile motion. And there's a lot more stuff in physics you would want to figure out, but we're sticking to what we can do for now. So the first question is, when will the height be 86 feet? This has nothing to do with the maximum or minimum, so we're not going to find the vertex at all. What it's telling us to do is replace h, our height, with 86, then solve for t. All right, so I'm going to go ahead and do that. In our equation, we have 86 equals negative 16t squared plus 77t plus 12. All right, unlike with a lot of the problems we've done, this one's not already set equal to 0, so you got to make it equal to 0 first. Then I can tell you right now, with how messy these numbers are, just use the quadratic formula. It's very unlikely in a word problem you'll be able to factor. All right, so we've got 0 equals negative 16t squared plus 77t, and then 12 minus 86 is negative 74. All right, so I'm going to go ahead and use the quadratic formula on this. I'm not even going to try to figure out if I can factor it. So we got t equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Let me go ahead and just write the equal sign down there. B is 77. We got negative 77 plus or minus the square root of 77 squared minus 4 times a, which is negative 16, times c, which is negative 74, all over 2 times a, which is negative 16. I'm going to give myself some more room. And what you definitely want to do is, for this one, the numbers are huge. Type it in your calculator. We know we want to simplify the inside of the square root first. So we got 77 squared minus 4 times negative 16 times negative 74. And we get 1,193 inside the square root. We got negative 77 plus or minus the square root of 1,193 all over 2 times negative 16 is negative 32. I don't even want to think about how to factor this number, so just split it up, the fraction now. Actually, you don't have to split up the fraction for this one because we're going to use our calculator. Just split it up over the plus and minus, since we will use the calculator to round. So what I mean by that, instead of making two fractions, just write the whole thing with the plus, and write the whole thing with the minus. And now use your calculator to get each one. Let me move this back over here. All right, so the numerator, put it in parentheses because we have this minus and plus. We got negative 77 plus the square root of 1,193. Make sure if you're on an older one, you just close the parentheses around the square root, so you'll have the double parentheses here because you have to close out the numerator. Then we want to divide by negative 32. And we get the first answer 1.33 because we went around to 2 spots. And then for the second one, I'm going to use a little shortcut here, hit second and enter, because the only thing that changes is the plus to a minus. And we get 3.49. And it's okay to have two answers here. In fact, it should make a little bit of sense. It's asking, when will the height be 86 feet? Well, when it's thrown up, it's going to hit 86 going up once, and then it's going to hit 86 falling down. Right, so you don't have to worry about throwing one of these answers away. They both make sense. Right, part B asks, when will the object reach the ground? Well, what is it asking you to do? Well, it's asking you when, so we want to solve for t. So we want, what is t when the height is 0? Because the ground is at 0 height. Now, unlike the previous problem, we should only get one answer for this. Why? Because it's only going to hit the ground once. I mean, it might bounce a little bit, but what it's asking is, when does it first hit the ground? But we're going to solve it just like from before. We're going to plug in the h equals 0 to our equation and solve it using the quadratic formula. Right, 0 equals negative 16t squared plus 77t plus 12. Now the nicer thing about this one, it's already set equal to 0. So just solve using the quadratic formula. You can use it right away. We got t equals negative b. b is 77 plus or minus the square root of b squared minus 4 times a, which is negative 16, times c, which is 12, all over 2 times a, which is negative 16. Now, one thing, you don't want to do, just because you use the quadratic formula up here doesn't mean you have any idea what the answer is going to be down here. You have to redo the whole thing. But we'll do the same thing as before. Simplify the inside of the square root. So we got 77 squared minus 4 times negative 16 times 12. And this time we get 6,697 inside. All over 2 times negative 16 is negative 32. Now we split it up over the plus or minus, just like last time, because we're going to use our calculator. I got negative 777 plus the square root of 6697 over negative 32. And same thing with the minus. And we will get two answers here because we're going to get one for each, but we'll see how to deal with the one answer thing afterwards. All right, so let's work it out. We got negative 77 plus the square root of 6697 divided by negative 32. We get negative 0.15. And then we do the same thing with the minus. So I'm going to do what I did before and just copy it and switch it with a minus, and we get 4. I clicked out of that too fast. 4.96. Now you just have to ask yourself which one makes sense. We're talking about time here. Time cannot be negative, so it can't be that one. Which means it is the 4.96. It takes that long to reach the ground. So 2 examples of when you might see the use of the quadratic formula, but it could happen in any word problem, especially if it doesn't ask for the maximum or minimum. Part C and D are exactly that. It's asking for the maximum height, when will it be there, and how high is it. So here we want the maximum height, which means we want the vertex for both parts. Now the first part is asking when, so what is t at the vertex? Well, if we scroll up to our equation, t is in the place of x, so it's really telling us plug in that formula for x of the vertex to find the maximum height when it happens. We got t equals negative b over 2a, our vertex formula. B is 77 and a is negative 16. Now I'm going to simplify this a little bit by hand first because it's easier than just typing in the calculator right away. 2 times negative 16 is negative 32. And then what is negative 77 divided by negative 32? Remember, we want to round to 2 spots. It's 2.41. That's how long it will take to reach its maximum height. And just like with the other word problem, once we get the x, or in this case the t value, we plug it in. We're going to plug in to get the actual maximum height. Now, one thing I would recommend is not plugging in the rounded thing. Plug in the whole decimal, which for us is 2.40625. All right, so we do that. Our formula is here, so I'm going to reference this. Plugging in this for t, we get negative 16. times 2.40625 squared plus 77. Then plug that in for t again. 2.40625 plus 12. And, really just type this whole thing in your calculator. Do as much at a time as you're comfortable with. Here I got negative 16 times 2.40625 squared plus 77 times 2.40625 plus 12. Oops. No, stop. And I get 104.64 feet. Is the maximum height. Right? But that's all there is to it. If you use the 2.41, the only problem is you run the risk of rounding before your final answer for this part. I'm not saying it would end up being wrong. We can actually even check, but mine might work out here and yours might not. So if we plugged in 2.41, we would actually get the same thing. 104.64 would work. But anytime you round an answer and then use that in your next answer, the next answer could be rounded farther off than you want. So just be careful about that. But that's it for the quadratic applications.